Hey y'all, welcome to lesson 2.4. We are going to be talking about how to solve word problems in chemistry. There's a method called the factor label method, which is super helpful to organizing and solving these problems that we'll be doing for the rest of the semester. Um, just a few little points here at first. This factor label method is used to convert units from one to another. Um, Often from mass to volume, if you know the density. Most importantly, we will be using it later on to predict the amount of product that we create with a chemical reaction. So if there's a chemical reaction going on, we need to predict how much product we'll be making. This happens in industry all the time. Let's say I wanted to make 2,000 aspirin. I don't know, just pick something at random. I used to work for a pharmaceutical company, so lots of my examples are that because it's what I used to do every day. So my boss wants me to make these aspirin. I need to know how much stuff to start out with to make those aspirin. Do I have enough? Um, so this method I used it every day in my job um, to figure out solutions to problems of chemical reactions. So we're going to do a couple examples, and then I'm going to let you practice some on your own. But our first example right here. So scuba tanks, a specific brand of scuba tank, has a density of 0.0437 kilograms per liter of oxygen in it. So this is just the brand, this specific type of scuba tank, right? Um, the scuba tank that we have, so we have one that is this brand. Right now it has 11.0 liters of oxygen in it. And we want to know how many grams of oxygen are in that tank. We know the liters, we want to convert that to grams, just like we said here, converting units. Right? So here are the steps that we're going to work through to do that. Okay? These steps will serve you well in all of your chemistry work in the future. So first step, we are going to find and write down the key measurement that our answer will depend on. Okay, so we look back at the problem. The key measurement that our answer will depend on is right here, 11 liters. Right? Remember I said this is our specific oxygen tank. We know liters, we want to know grams. So this right here is our key thing, 11.0 liters. That is going to be our starting point for figuring out our problem. Okay. Step 2, what units will the final answer have? We look back at our problem. What's the question? It says how many grams of oxygen are in the tank. So my final answer needs to be in grams of oxygen. I'm going to abbreviate that O2 because it's easier. Okay, so now I know where I'm starting. I know where I'm ending. I got to figure out the pathway to get there. That's step 3. Well, not quite yet. Step 3 are the steps that are going to help me along the path. Okay, so I need to write down all the conversion factors that I need to get from liters to grams. So I look back at my problem. My first conversion factor is right here. It tells me that I have 0.0437 kilograms is equal to 1 liter, right? Kilograms per 1 liter, that many kilograms in 1 liter. That's my ratio. But I can turn it into this equals this. My next conversion factor, not written in the problem, but I see I have to get from kilograms to grams. So I look it up, or I just know from my metric system time that 1 kilogram is equal to 1,000 grams. That will be helpful later on. Okay. So now I have all my pieces. I need to put them together. Here's how I'm going to put them together right here in these little parentheses. Okay. So the first thing I'm going to do is I'm going to write down my starting point at the beginning, 11.0 liters. The next thing that I'm going to do is I'm going to put my ending point right here. I need to get to grams of O2, grams of oxygen. So that's where I'm ending up, which will help me fill in the other pieces. Okay. This right here is just going to be a 1, a placeholder, always. Okay. Then I need to figure out my conversion factors and plug them in here appropriately. Okay. Because I have liters in the numerator here, I want liters in the denominator down here. 1 liter. And 1 liter is equal to 0.0437 kilograms. Okay. The reason I do this is because I need my liters to cancel. And numerator and denominator, they will cancel each other out. Okay. Now I look at my next conversion factor. I see I need grams in the numerator, right? And so I know from that 1,000 grams is equal to 1 kilogram. So that's my next conversion factor. And again, I know that my units will cancel out. Kilograms in the denominator, kilograms in the numerator. Okay. So that's my 4th step, is to kind of write it out. Now my 5th step is to cross out the units and then multiply. So I'm just going to do that up here instead of rewriting it. I got liters in the numerator. I got liters in the denominator. They cancel out. Kilograms in the numerator, kilograms in the denominator. They cancel out. Okay. So then I want to multiply across the top here and then multiply across the bottom. That gives me 1 ratio. So 11 times times 1,000, right, is actually 481. When you multiply those out, multiply, 1 times 1 times 1, it's just 1. All my units have canceled out except for this grams of O2. So I know my units are going to be grams of O2, which is where I said I needed to be at the end. So I'm pretty happy with that. And then I can just divide. This is easy. 481 divided by 1 equals 481 grams of oxygen. So my 11 liters of oxygen weighs 481 grams. How many grams? 481. Right. So these steps are super important. Memorize them, use them. In the next video, we'll do another example.